All right, today we're going to be looking at section 5.4, inverses of functions, and we're just going to jump right into it. Most of it is not very difficult, and so I will explain what you need to know as we go through it. So this first problem wants us to find the inverse. So when you have a set of ordered pairs, what you want to do to get the inverse is you're just going to switch x and y. You're going to flip-flop everything. So when you do inverse, the notation that they show you in the text, if you have some function of x, the notation for inverse is this f negative 1 power x. So all that means is you're going to be changing x and y position. So here you would have an ordered pair, it would be xy. When you do the inverse, it is now going to become yx. And you're going to do that for every ordered pair. So you're just going to be switching x and y and then solving from there. But when you have ordered pairs, you don't solve. When you have a function, you actually have to solve. Okay, so in this example, we're just going to change the order. So it's going to be 5, negative 8. And then we're going to have 8, 5. So I'm just taking each of these one at a time and switching the order. Negative 7, negative 3, and then 4, negative 2. So just switch the order. Okay. Now there's a part 2. So part 2 says find the domain and the range of the inverse. Okay. So what you need to be familiar with is normally domain, okay, is referring to the x values, and range is referring to the y values. However, when we're considering the inverse, okay, these also get flip-flopped. So whatever was your domain is now your range, and your range is now your domain. So the same way we switch x and y here, we switch it down here with our domain. So from our original, and this is showing you original, it doesn't have that negative 1 notation up there. So this is the original. The domain is now the range and vice versa. So when I do domain, I'm now looking at the y values instead of the x values because that's getting switched. So my y values are 5, 8, negative 7, and 4. And then for my range, for the inverse, I'm now doing the x values because they also get flip-flopped. So negative 8, 5, negative 3, and negative 2. So all you're doing when you have a set of ordered pairs is changing x and y, just switching everything up. All right, so number 2, this one says consider the following relation. Okay, we're going to find 4 points on the inverse. Okay, so inverse, you want to change x and y and then solve for y. That's the way I recommend you do it. So right now you have this equation. You have x equals negative 2 absolute value of y, and then minus 2. All right, we're going to change the position of x and y. So this is going to become y equals negative 2 absolute value of x minus 2. Now, when I do that, then I would solve for y. Well, look, y is already by itself. So this is my inverse. So you can write it like this, but it's better to go ahead and use that notation. F negative 1 of x, put it in function notation, is equal to negative 2 absolute value of x minus 2. This is how you know that we're dealing with inverse. So this is my inverse. And from here, we are going to find 4 ordered pairs. So I'm just going to make a table, x value and y values, and then I'm going to pick some really small ones, 0, 1, 2, 3, and we're going to plug those in. So if I plug in a 0, 0 times anything is 0, minus 2, give me a negative 2. Plug in a 1, 1 times negative 2, minus 2, give me a negative 4. So it looks like we're counting by 2's each time I go down based on the numbers I picked. So if I plug in a 2, I'm expecting to get a negative 6 here. Plug in a 2, 2 times negative 2 is a negative 4. Negative 4 minus 2, negative 6. And so my last number should be a negative 8. But let's verify it. 3 times negative 2 is a negative 6. Negative 6 minus 2, negative 8. So here are 4 ordered pairs on the graph of this inverse that we have worked out. And we'll just put those in. 0, negative 2. And then 1, negative 4. Went too far. And then 2, negative 6. And then 3 and negative 8. Okay, so now we have part 2. We want to find the domain and the range of this inverse. So you can do one or two things. You can graph it and you can sketch it based on transformations that we've previously talked about. So let's talk about how this graph is being transformed from the original. So if we had original absolute value, it would be looking like a V shape right at the origin, centered at the origin. What happens here, this minus 2 will move this graph down 2 units, so it would start here at negative 2. And this negative 2 out front would flip it. So instead of going up, your parabola would now be going down. Or your, not parabola, your graph of your absolute value, the V shape. So this is what it would look like. And from here, we can tell that our domain is going to be all real numbers. So domain, and this is the inverse, and that's what they want. So negative, infinity. Maybe I could have done all real numbers, but we'll just do the infinity here. Negative infinity to positive infinity. And then our range, you always go from smallest to largest, but we have 2, negative 2 that is, all the way down to negative infinity. So negative infinity up to negative 2. And we want to do the half open closed interval. Negative infinity up to negative 2. And then that will give us our range of our inverse function.